The title of our project is Workload-Based Software Rejuvenation in Cloud System in the domain cloud computing. Let's see the brief explanation about our project. Cloud system is the fastest growing field in our ICT. It meets computing demand steadily on the rise with the supply of service model after public utilities such as energy and gas traditional available and at high fees. Virtualization allows to instance one or more virtual machine on top of single physical machine managed by a virtual machine monitor. Software rejuvenation is a protective fault management technique that involves terminating an application, cleaning up the system internal state and restarting is to prevent the occurrence in failure future. In this work, we propose a technique to model and evaluate the VMM aging process and to investigate the optimal rejuvenation policies that maximize the VMM availability under a variable workload condition. Starting from a dynamic reliability theory and adopting symbolic algebraic techniques, we investigate and compare our existing time-based VMM rejuvenation policies. The VMM time-based will be in the form of, at the first stage, we will start our timing process, that is before the rebooting of software. That is when the user finds the software aging. The software aging is mainly dependent degradation over time of an application performance may lead to low availability due to the performance program technical caused by the software bugs. The software rejuvenation is a cost-effective technique for dealing with the software faults. In this case, when the user finds the software aging and that is a software failure, the user has to reboot the software. It's a main goal on our proposed method. When the software is get rebooted, before that the timing has to set. When after the rebooting has been processed, next stage we have to fix our timer, that is our firing timer. Both the timer will be compared at this state space mode. This is our main focus and we improve our software bugs. On the one hand, an analytical technique that allowed to represent any generic failure and repair distribution, rapidly modeling changes in the workload through the conservation reliability principles. A variable timer rejuvenation policies aiming at optimizing the software availability is a case workload changes. The optimized results show the proposed variable timer policy outperforms the fixed timer one, also considering the different impact of the workload of the aging process. Let's see the data flow diagram of our project. We have two levels at the level 1 and the level 2. At the level 1, we are starting our process. We have the home domain and the multiple VMware we are using. We are starting our process. We are started the server first. And the server will be started for the home domain and the VM1 and the VM2. We are getting the workload. The workload will be made in the form of software how the workload has been based, and we are analyzing the software aging and the failure based on the workload. At the level 2, we are analyzing the software aging. If the failure occurred, we have to fix our timer. If the failure has not occurred, we are concluding that we have an efficient software. If the failure has been occurred, we have to fix our timer and reboot our software. After rebooting our software, we are finding the firing time, that is after the rebooting has been processed time in our software. Then we are analyzing the workload based on our timer. Then after that we are concluding that is we have an efficient software. This is about our data flow diagram. Let's see the demo of our project. This is our home. Now the agent is going to monitor the workload of the home domain VM1 and VM2. When I click on this home button, I got an information that is we have to start your server first. So I am going to start my server. My server has been started here. I am clicking the start server button. Now I am getting the availability for the home domain. So now the workload which I got is 188. Same the process, I have to find the workload for VM1 and VM2. So before that I have to start my server in VM1 and VM2. Now I am going to start my server in both VM1 and VM2. Here I am starting the server at the VM1. My server has been started here, and here at the VM2 I am starting my server. So my server has been started here. Now here I am going at my VM1. I am going to check my process. Here I got an information that the software failure has been unable to reload. So I'm clicking on this button. Here I'm going to reboot my software. I'm going to fix my timer. My timer has been fixed here. Then I got an information that is reboot your software. So I'm going to click on this button. Here I got an information that is your system will be restarted your software. So my process will be get restarted here. that is here my whole of an application has been saved and the process has been closed, and my process is going to reload it here. And when I click on this VM2 application, the same process will be happened also here. When I click on this check button, I am checking the process whether the how the software the same information I got, that is software failure has been occurred. So I am going to fix my timer and I am going to reboot my software. Here the whole process has been reloaded. The process has been saved and my process is getting reloaded here. Now my process is get rebooted and my whole application is get restarted now, and this is my resume button. Now I'm going to click on this resume button at my VM1 stage. Here I'm going to find the VM aging and the failure. This is actually a firing time, that is after the rebooting process. My time will be in the form of millisecond. And when I click on this button, this is my monitoring. I'm going to monitoring my application, that is a load monitoring, how the load has been monitored here. I'm finding the load monitoring age at each stage. It's getting load now, and when I click on this getting my VM application, that is my name of the VMware is VM1 and total number of VMware I am getting used now. And here I am going to finding the application, that is the booting time in millisecond, also the firing time, and the new firing time has been found with the help of this formula. And the same process will be continued in our VM2 also. When I click on this resume button, my process, that is I'm going to finding the VM aging and the failure. The firing time have been founded here. The same thing as the that is the load monitoring. At the first level, the load level will be at the high, and now the load balancing will be decreased. So I can put more number of works. So when I close down this button and when I click on this button, I am getting an information, the name of the VMware is this VM2 and the total number of VM I am getting used now. And when I click on this getting button, the booting time and the firing time and the new firing time occur, that is with the help of this formula has been founded here. Now I am closing my VMware. Now I am going to find my state space model. The state space model is actually, now I am using the VM1 and VM2. If I use the N VMware, that is consider the state S, the state S will be the VM1 and the state S+1 will be the VM2. And how will be the form when I use the N number of VM in my what will be the form when I use the N number of VM in our system. So this I am going to initialize my state space will be in the form, and the VM rectified will be 2. And when I at the stage 1 I am founding the time will be in this format. And when I click on this get button, here I am founding the middle software, that is we have S+1, S-1 and S to the N power of state. And when I go into the N power of state, I will get the value, this value with the power of -100 N state. And my state space will be in the format of this graph. That is, here I found the state at the first level and I am deep on and decreasing in my load balancing state. And when I click on this limbs, that is when I found with the home load, the workload which I found is 188. And when I click on this button, the sublinear will be this format and the linear and the superlinear will be found. This calculation will be formed with the help of parameter adapted state evaluation, that is using a web fuel failure time formula. And when I found the workload for VM1, when I click on this rectify button, the workload for VM1 will be the 36 and the sublinear, linear, superlinear will be get calculated, and the similar as the VM2 I am rectifying it, and I found the workload will be 47 based on the superlinear, linear and the sublinear, linear and superlinear will be get calculated. And when I click on this rectify button, now I am going to now everything, all the process, that is the VM software reloaded and every process has been got over. Now I am going to at the next stage of my level, I am going to check my software stage, that is the main goal of our proposed will be periodically the software has to be rectified and will get reloaded. I am founding the rectified load software will be VM1 and VM2. So I am getting the that I have to check my loaded process. That is, when I click on this button, here I found the highly efficient software. There is no problem at the VM2, and the same process will be carried out here. When I click on this button levels, if any problem has been occurred, we have to reload our software. Highly efficient software has been found, because for workload will be 36 and now the workload found will be the 12, and same for the VM2. When I click on this check button, then we are finding the highly efficient software. There is no process and there is no problem at the software. That we are finding the highly efficient software has been founded here. Now when I click on this next button, I am getting in the mode analysis and evaluation technique. When I click on this button, the timer will be get alarmed. That is timer and the firing timer about a project. Thank you.